Welcome back, learner. It's so great to have you with us today. For this deep dive, we are on a very specific, highly technical mission.
Yeah, a really important one too.
Exactly. We are unpacking the VMware 5V0-36.22 exam. Now, if you are gearing up for this certification or, if you simply want to understand the modern telecommunications landscape, we are going to tear down the core concepts tested on this exam to see how these networks actually operate in the real world.
Right. We are focusing intensely on the exam questions and the correct answers today.
Yeah.
But we aren't just going to read a list of flashcards.
No, definitely not.
To truly master the VMware Telco Cloud architecture, you have to understand the why behind the answers. I mean, the exam rigorously tests your grasp on how massive telecom infrastructures are built, secured, and scaled using software-defined principles.
Yeah, so let's get you oriented on the logistics first. If you are sitting down to take the 5V0-36.22 tomorrow, here are the baseline stats you're dealing with. You have 105 minutes on the clock.
Which goes fast.
It goes very fast. You are staring down 50 multiple choice and multiple selection questions. It will run you about $250 depending on your region. And to earn the credential, you need a scaled passing score of 300 on a scale of 100 to 500.
It is a demanding test because, honestly, the stakes in telecommunications are incredibly high. The industry has aggressively shifted from proprietary hardware-heavy networks to software-defined cloud-native environments.
Yeah.
So the questions on this exam reflect the very real architectural decisions and challenges that engineers face when deploying something like a 5G core or a modern radio access network.
Okay, let's unpack this. We're going to walk through the major technical pillars the exam focuses on, starting right at the foundation, which is networking and automation.
The absolute bedrock of the whole system.
Right. So question 1. The exam frequently asks candidates to identify the core foundation. The question reads, which product provides the core software-defined networking and security foundation for the VMware Telco Cloud?
And the options.
The options are A, VMware NSX, B, VMware Workstation, C, VMware Fusion, or D, VMware Player.
Well, the answer it's looking for there is A, VMware NSX.
NSX. Yeah.
And what's fascinating here is how entirely NSX shifts the telecom paradigm.
Yeah.
Historically, if a telco needed to route traffic, implement a load balancer, or set up a firewall between core components.
They had to buy physical boxes.
Exactly. They purchase specialized proprietary hardware appliances. NSX abstracts all of that. It delivers switching, routing, and firewalling entirely in software running on commercial off-the-shelf servers.
And in a telco context, that software-defined approach is what actually makes microsegmentation possible at scale, right? Like, if you are deploying a 5G network, you need to tightly isolate different network slices or isolate the control plane from the user plane.
Right.
NSX allows you to enforce those consistent security policies across massively distributed infrastructures, from the central data center all the way out to the far edge.
Precisely. You cannot manually configure physical firewalls across thousands of cell tower edge sites. NSX provides the programmatic API-driven network that automated systems can control, which brings us right into the next major exam focus.
How you actually deploy that massive software-defined infrastructure.
Yes, exactly.
Because you don't just click next, finish to build a national cellular network.
I wish it were that easy, but no.
So this leads us to question 2, focusing on the builder. The question is, which tool is used to automate the deployment and initial configuration of the VMware Telco Cloud infrastructure components? Is it A, Cloud Graphic Designer, B, System Maintenance Tool, C, Telco Cloud Builder, or D, Network Speed Tester?
The correct answer is C, Telco Cloud Builder. And let's talk about the historical pain points that make this tool an absolute requirement.
Oh, the manual deployments.
Right. Before dedicated automation tools like Telco Cloud Builder, deploying a virtualized infrastructure manager, or VIM, was a brutal manual process. Engineers were individually installing vSphere, configuring vCenter, deploying NSX managers, and manually stitching the network configurations together.
Which just invites mistakes.
Across a telecom footprint, human configuration drift is inevitable. Someone typos an IP address or misses an MTU setting on an edge node, and suddenly your high-performance network function just fails to deploy.
And troubleshooting that needle in a haystack takes days. Telco Cloud Builder solves this by standardizing the installation of all those components using strictly predefined workflows.
Yeah, it takes a validated design and executes it programmatically.
So it drastically reduces deployment complexity, ensures absolute consistency across the board, and essentially eliminates human configuration errors during the foundational build.
Exactly. It sets the pristine stage. But once the infrastructure is built, you have to deploy the actual telco applications onto it. This is where the exam shifts focus toward application modeling.
Right, segment 2, blueprints and secure storage.
There is a heavy emphasis on knowing which modeling language is used.
Let me read question 3 for the learner. Which modeling language is used within the platform to describe the topology and relationships of cloud-based applications? A, HTML, B, CSS, C, TOSCA, or D, SQL?
The exam answer is C, TOSCA.
TOSCA, which stands for Topology and Orchestration Specification for Cloud Applications.
The exam doesn't just want you to know the acronym, though. It wants you to understand its function. In the telco cloud, TOSCA templates act as the master blueprints.
Blueprints for the applications.
Yes, they describe the network functions, every single dependency they have, and their entire lifecycle operations. It's vital to understand how complex a modern cloud-native network function, or CNF, actually is.
It's not just a single web server.
Far from it. It's rarely just one container. It might be dozens of microservices that need to be deployed in a specific order, connected to specific internal and external networks, and allocated specific resources. A TOSCA blueprint maps all of this out in a standardized, declarative way.
So when Telco Cloud Automation receives a request to deploy a new 5G service, the orchestration engine reads that TOSCA blueprint and knows exactly how to build the service, wire the networking, and manage its state.
It's the language that translates intent into actual deployed software.
Now, speaking of deployed software, the exam also heavily tests on container security and storage. This is question 4. What is the primary role of the Harbor component within the VMware Telco Cloud architecture?
Let's hear the options.
A, physical load balancer, B, VM graphical interface, C, network encryptor, or D, private registry for storing container images?
The answer is D, private registry for storing container images.
Yeah.
And we really need to look at why the exam specifically emphasizes a private registry in this architecture.
Right, because any engineer familiar with Kubernetes knows about public registries like Docker Hub.
Exactly. But in a telecom environment, you are dealing with critical national infrastructure. You cannot pull a container image from the public internet and just run it in a 5G core.
No, absolutely not. But Harbor isn't just a dumb storage locker for code, is it? It actively manages, scans, and signs these container images, which actually brings up an interesting operational challenge.
How so?
Well, if Harbor is constantly scanning for common vulnerabilities and exposures, the CVEs, and requiring cryptographic signatures before an image can be deployed, doesn't that inherently slow down the CI/CD pipeline?
It introduces unnecessary friction, yes. But in telco, the tolerance for risk is virtually zero. If a compromised container or an image with a known vulnerability makes it into production, it could literally take down mobile services for millions of users.
So the friction is worth it.
Completely.
Yeah.
Harbor integrates directly into the pipeline so that security validation is automated. It ensures that only verified, cryptographically signed, and vulnerability-free workloads ever make it to the Kubernetes clusters. It's a non-negotiable layer of the telco security posture.
That makes perfect sense. Let's pivot from the software layer down to the physical compute layer for segment 3, because the exam dedicates significant attention to heavy lifting, hardware, and resource management.
This is where things get very specific to telecom.
Let's look at question 5. Why are performance profiles used when deploying worker nodes for telecommunications workloads? Is it A, colorful management reports, B, identifying server rack locations, C, ensuring consistent hardware and operating system settings, or D, calculating cloud subscription costs?
You're going to want to select C, ensuring consistent hardware and operating system settings. This is actually a major departure from traditional enterprise cloud philosophy.
How so?
In a standard enterprise cloud, the goal is to abstract the hardware entirely. You just ask for compute, and you don't really care what physical server provides it. But telco workloads, especially user plane functions that process millions of data packets per second, they are incredibly demanding. They require deterministic performance.
Right. And deterministic performance means you need to care deeply about the underlying silicon. Performance profiles are used to standardize the worker nodes by defining extremely rigorous low-level parameters.
Yes, exactly.
We are talking about specific NUMA node alignments, deep-level BIOS settings, CPU pinning, and enabling technologies like SRIOV or DPDK for direct hardware network access.
And without performance profiles, configuring those low-level host settings across thousands of servers manually would be impossible to manage. The profile guarantees that when a telco application requests a highly tuned execution environment, the worker node is precisely configured to deliver that Formula One level of performance.
And this strict standardization ensures compliance with the rigorous latency and throughput requirements of the network, which feeds perfectly into question 6, another major concept, the exam tests. Resource allocation.
Resource pools.
Exactly. Question 6 asks, what is the purpose of a resource pool in a virtualized telco environment? Options are A, collect rainwater for cooling, B, reserve specific processor and memory for critical tasks, C, share admin logins, or D, provide a list of hardware vendors.
The answer is B, reserve specific processor and memory for critical tasks. This again highlights the massive difference between enterprise IT and telco.
Right, because enterprise virtualization is built on the concept of oversubscription, putting more virtual machines on a host than the physical CPU cores can theoretically support, banking on the fact that they won't all spike at the exact same time.
But in telco, the noisy neighbor problem is a fatal flaw.
Yeah, if a minor management application suddenly consumes a massive amount of CPU, and it starves a critical routing function on the same host, you drop packets.
Which means dropped calls. By utilizing resource pools, you are drawing a hard boundary. You are allocating and reserving a guaranteed chunk of CPU and memory specifically for designated workloads.
It enforces performance isolation. Critical network functions maintain guaranteed resource availability, meaning the core service remains reliable even if other non-critical VMs on the cluster are experiencing massive load fluctuations.
Exactly. It's all about predictability.
Okay, let's look at how the architecture handles legitimate traffic fluctuations. Segment 4 is all about elasticity and on-the-fly configuration. The exam features scenarios testing exactly this.
Right, how the platform adapts.
Question 7 reads, how does the Telco Cloud Automation Platform handle an increase in traffic demand for a specific Kubernetes workload? A, decrease priority of other services. B, restart physical network switch. C, manually migrate VMs. Or D, add more worker nodes to the workload cluster.
The correct approach and the answer on the exam is D, adding more worker nodes to the workload cluster. If we connect this to the bigger picture, the exam is testing your understanding of horizontal scaling within a cloud-native architecture.
Which is completely different from the old way of doing things.
Historically, if a monolithic telco application needed more power, you had to scale vertically. You had to take it offline and provision a physically larger server with more RAM and CPU.
But modern telco cloud automation integrates with Kubernetes Cluster API to handle demand dynamically. When the system detects that a specific network function is reaching its capacity limit, it doesn't try to make the existing worker nodes bigger.
Right.
Instead, it horizontally scales the infrastructure. It automatically provisions and adds entirely new worker nodes to the cluster, and then Kubernetes schedules new application pods onto that fresh compute capacity.
This distributes the workload across a wider pool of compute resources without any service interruption. Think of a localized signaling storm, maybe a massive stadium event, or an emergency situation where cellular traffic spikes unpredictably in one geographic area.
Horizontal scaling provides the immediate elasticity needed to maintain service continuity.
Exactly.
That dynamic flexibility is a core theme of the exam, and there is another exam concept regarding flexibility that trips up a lot of candidates.
Oh, late binding.
Yes, late binding. Let's look at question 8. What does the term late binding refer to in the context of network function deployment? Is it A, connecting power cables late, B, applying specific configuration data at the time of instantiation, C, updating expired licenses, or D, scheduling night maintenance?
The answer you need to know is B, applying specific configuration data at the time of instantiation. This is a crucial concept for managing telco workloads at scale.
How did they do it before?
Well, in older deployment models, engineers would often bake site-specific configurations, like static IP addresses, host names, or specific routing rules, directly into the base image of the virtual machine or container.
Here's where it gets really interesting. Late binding sounds great in theory, but doesn't injecting configurations at the absolute last second introduce a new risk instantiation failures if the data payload is malformed? If you bake it into the image, you know it works.
You're highlighting the exact trade-off engineers have to weigh.
Yes.
If the injection payload, which is usually handled via something like Cloud Init, is malformed, the node won't boot correctly. However, Telco Cloud Automation mitigates this with strict payload validation against the TOSCA blueprint before deployment. The benefit far outweighs the risk. If you bake IPs into images and you have 500 edge sites, you have to maintain 500 unique static images.
That is an operational nightmare.
It really is.
So late binding fixes that by keeping the base image completely generic, just a single golden image. That single image is distributed to all 500 sites. Then, at the exact moment of deployment, the orchestrator injects the site-specific environmental data.
It drastically reduces storage overhead, simplifies lifecycle management, and makes your workload catalog highly standardized and reusable.
Moving up the stack to segment 5, bridging worlds and maintaining visibility. The exam explores how these private telco clouds interact with the broader ecosystem. Let's hit question 9.
To do it.
Which component is used to establish secure and optimized connectivity between a private telco cloud and a public cloud provider? Options are A, hybrid cloud extension, B, LAN cable, C, public internet browser, or D, standard telephone line.
The exam is looking for A, hybrid cloud extension, or HCX.
Now, HCX is an incredibly powerful tool, and the exam tests its primary use cases. It isn't just a basic VPN tunnel between two data centers, is it?
No, it actively supports advanced workload mobility and Layer 2 network extension. Layer 2 extension is the critical piece here.
Why is that so important?
Normally, if you move a workload from a private data center to a public cloud, it moves to a new subnet, which means it needs a new IP address, which means you have to update DNS, load balancers, and security firewall rules. It's a massive migration project.
But HCX stretches that Layer 2 network right across the boundary. You can take a complex application running in your private telco cloud and live migrate it into a public cloud environment without changing its IP address or its MS address.
Exactly.
The networking and security policies seamlessly bridge the two infrastructures. It allows telcos to burst workloads to the public cloud during peak demand or utilize the public cloud for disaster recovery without having to completely re-architect the application's network identity.
Which is incredibly powerful. And that brings us to the final critical layer of the architecture and a major focus of the 5V0-36.22 exam. Day 2 operations and visibility.
The all-seeing eye. Let's read question 10. Which solution provides comprehensive health monitoring and visibility across the entire telecommunications network? A, standard spreadsheet, B, manual log review, C, basic email notification, or D, area operations for networks.
You're going to confidently select D, area operations for networks.
Formerly known as Virtualized Network Insight for those who've been around the VMware ecosystem for a while, the exam tests your understanding of why this specific tool is necessary. It goes way beyond basic up and down monitoring.
Exactly. Area operations for networks provides deep, flow-level analytics. In a highly distributed telco cloud, traffic is constantly moving east-west between microservices and north-south to the internet. Area analyzes these actual traffic flows,
Giving you real insight.
It helps engineers map out application dependencies, plan microsegmentation security rules for NSX, and proactively identify network bottlenecks.
It's essentially a predictive analytics engine. It isn't just alerting you that a link went down. It's showing you that packet latency between a RAN component and a core component is trending upward, allowing you to reallocate resources or troubleshoot the network path before the end user ever experiences a dropped call.
Proactive rather than reactive.
Thank you so much for joining us on this deep dive into the VMware 5V0-36.22 exam architecture. We hope this gave you a clearer understanding of not just the right answers, but the real-world engineering behind them. Keep questioning, keep learning, and we will see you next time.